Here we are at 7. I don't think this will take very long. I might give another example for you guys. Alrighty. Okay, so what do we got here? We're gonna match this 10. We got 10 divided by x minus 3. Okay, so what's going on here? Anytime you got an x down in your denominator, we need to remember we cannot divide by 0, okay? This would be undefined. So x can never be some value that's going to give you a 0 in your denominator. Do not divide by 0. We can't do it. X will never be that number. So we're thinking, what number is x that's going to give me 0 down here? Something minus 3 equals 0. So let's write it out. A lot of people are going to see it right away. But if you don't see it right away, you could just write out x minus 3, set it equal to 0, get x all by itself, plus 3. To cancel this out, I got to do the same thing to the other side. Got to keep it even. If you do something on one side, you do it to the other. 3. Let's double check. Is 3 minus 3 equal to 0? It most definitely is. If I plug in 3 for x, I'm going to get 3 minus 3, and that would be 0. So x can never be 3. So when you got something in the denominator like that, you get these vertical asymptotes where the graph is just never going to go there because x can't be equal to that value. And what we're looking at here is this graph right here. It's going to be this one. Here's the one we're looking for. Let's circle that, okay? But don't give up yet. Don't stop the tape. Keep listening if you're with me here, please. Let's talk a little bit more about this. What if... I'll keep that up here. We never divide by 0, okay? It's undefined. Maybe I'll just do a big red. Don't do that. Don't divide by 0. X cannot be that value that makes 0 in the denominator. We figured out already what the answer to 7 is. But what if the equation was plus 3? What if they gave us 10 over x plus 3? Well, let's go. Some of you might know already exactly what the answer is. So let's go see what that would look like. What we need to avoid making this denominator 0. So let's take the x plus 3, set it equal to 0, because we don't want 0 in the denominator. Let's figure out what that x is. That gives us 0. And if you do your inverse operation, you're going to go minus 3 from both sides. Cancel that out. We get x by itself. X equals negative 3. A lot of you guys aren't going to have to do all this work, okay? Some people might just prefer it this way, so I'm going to show you how to do it that way. If that's what it was, if they had said 10 over x plus 3, guess what? This would be our answer over here, this other one. Because when x is negative 3, we'd get negative 3 plus 3. We'd get 0. Down here, we can never divide by 0, so x is never going to be negative 3. So if they'd said 10 over x plus 3, we would have picked this g of x on the right. But they didn't. They said 10 minus 3. So we picked f of x. And if you got more questions about this, there's lots of other examples from 17. You could look back in your notes. We did lesson 17 together. There's probably several examples in there of what's going on right here.